Wow.
Yes, a little bit bigger.
Changed a little bit from the last one.
Now it's time to ship the scrubber to the test site in Canada to run it for real. Basil has tested a torpedo that could be used to store excess CO2. But the team want to explore other options. So Kevin O'Leary, the team's logistics expert, has hitched a ride with Professor Keith for a fact-finding mission to the North Sea. They're headed about 80 kilometers off the coast of Norway. This is the Sleipner natural gas platform. It stands 200 meters above sea level and weighs 90,000 tons. Each year it pumps up to 340 million cubic meters of gas from beneath the ocean. But it's what this rig pumps back below the sea floor that David Keith and the team are really interested in.
This machine captures 1 million tons a year of CO2 from natural gas and puts it into a rock formation about a mile beneath our feet, disposing of CO2 that would otherwise be vented to the atmosphere.
Sleipner produces $7.3 billion worth of gas a year. But before they can sell it, they have to remove the carbon dioxide that's mixed in, roughly 9% of the total volume. Most platform operators simply release excess CO2 into the atmosphere. But the Norwegians have found a way to safely store that carbon dioxide. Sleipner gets its natural gas from reserves trapped in porous rock, 800 meters below the sea floor. But other sections of porous rock are empty and serve as storage areas for the CO2. A satellite rig houses a CO2 separator, which removes the carbon dioxide from the natural gas. It's then pumped to the main rig and down into the porous sandstone at the rate of 3,000 tons per day. Sleipner has stored millions of tons of CO2 in the past 12 years. So Kevin and David are eager to learn more from the rig's engineer, Tor Torp.
This facility is to separate CO2 from the natural gas.
What's exciting is this proves you can put away significant industrial volumes of CO2 and dispose of it.
Torp tells Kevin that by storing their excess carbon dioxide, the rig owners avoid a stiff tax on CO2 released into the air.
Always about the money all of the time. That's
right.
That's why this technology works, because it's cheaper to stick it in the ground than put it in the air because of the tax.
So that's why if we want to see more of this, we need more economic incentive. More price on carbon going directly to the atmosphere will develop the technologies to solve this problem by finding ways to avoid putting it in the atmosphere or take it out and put it underground.
According to Torp, if carbon dioxide scrubbed from the air could be stored by ocean facilities like his, Professor Keith could forget about carbon dioxide torpedoes.
So how much in the long run could you put there?
The pore volume is equivalent to 600,000 million tons of CO2.
That's 22 times the world's total yearly emissions. If that much CO2 were taken out of the atmosphere tomorrow, it would reduce carbon dioxide to pre-industrial levels. Kevin's convinced the Norwegians have come up with a powerful technique to combat global warming.
They're separating so much carbon out of the natural gas here. Every day it's the equivalent of 300,000 cars. They capture the carbon, they put it away, it stays underground for the millennium. It's a fantastic process. This is how you solve the challenges of climate change.
Geological storage layers like these are common to most gas and oil fields, on land as well as the oceans. That gives Professor Keith hope for the future.
There's a natural, fortuitous connection between where we get gas and oil out and where we might like to put the CO2 in.
Keith's carbon scrubbing machines could be placed wherever the Earth offers the best natural storage facilities, including sites like this one.
The amount of CO2 in the atmosphere is evenly mixed. So that means wherever you build your air capture plant, you're basically scrubbing CO2 out of the air from everywhere.
The big question now is whether it's really possible to economically clean carbon dioxide from the air in the first place. The answer is now on the road, as the team moves David Keith's dream to the test site. With help from the Discovery team, David thinks they've finally created an energy-efficient prototype.
Actually, I'm just thrilled. We've had a few really lucky breaks in the last few months. We've been lucky enough to seemingly make sort of enormous progress. So we're on top of the world, actually, really thrilled.
Keith's machine is now ready for testing at a stadium in Calgary, Canada. This prototype embodies his dream of thousands of scrubber farms, each the size of this stadium.
Although from the outside, this thing looks pretty boring. It's just a big grey tube. What's going on the inside is actually pretty amazing. I mean, this machine could be a huge leap forwards, but only if it works.
The scrubber is powered by a portable generator that emits carbon dioxide.
Give it a try. All right. Like a lawnmower. One touch.
First touch.
To erase its own carbon footprint, the prototype has to scrub the same amount of CO2 from the air that's produced by the generator. Jen's fan will draw in air through the base, while caustic soda is pumped into the tower. When they meet, the CO2 is stripped from the air. If the exhaust air from the prototype has low enough levels of CO2, the experiment will have succeeded.
This may be the ultimate solution. This may be part of the solution. This may be the most cost-efficient solution. We don't know. That's why we're here.
Okay, I want to turn on the generator.
To get the most accurate results, the team will run the scrubber overnight. David Keith knows the odds of bad results are higher than success. But that's what experiments are all about.
There's a whole lot of ways you can make a mistake. Literally hundreds of ways you can make a mistake, and so you don't really know what it's going to do until you turn it on.
Keith's crew calculates the scrubber will have to remove 9 kilos of CO2 in 10 hours to erase the carbon footprint of the gasoline-powered generator. For this prototype to succeed, it has to perform 30 times better than the first model did.
20 pounds of CO2 is a tough target. And remember, that's what it's got to do just to cover its own emissions. If we can't beat that figure by a decent enough margin, then it's pretty much useless.
The sodium hydroxide, or caustic soda, that actually captures CO2 is loaded. And Jennifer crosses her fingers.
I saw it work in the fab shop, so at least I know the system works. We have no idea what it's going to do with the solution in it.
One of the attractive things about this process is this is a very simple chemical that's widely used in industrial processes.
David's dream now depends on 75 litres of chemical and the flick of a switch.
Okay, we're turning it on. There we go, it should be coming on slowly.
The data from the scrubber will appear on the scoreboard.
So we'll take it up to 50 hertz. Is it blowing?
As the scrubber revs up, carbon dioxide levels should be coming down as the cleaned air is expelled.
What you're looking at is you're looking at carbon dioxide concentrations in the ambient air, and I'm measuring it from that tube up there.
So you're basically a walking carbon dioxide meter, and
Yeah.
I am your computer slave.
Yes.